Bismillahirrahmanirrahim. Assalamu alaikum, dear students. In my last lecture, we evaluate three special integrals. Now, today, we will evaluate three more special integrals. And the first one is integral 1 by square root of a square minus x square. On evaluating this integral, we will get sine inverse x by a plus constant of integration c. Let us prove this. To find integration of 1 by under root of a square minus x square, we put x equal to a sine theta. Now differentiating x with respect to theta, we get dx by d theta is equal to a is constant and differentiation of sine theta is cosine theta. It is cosine of theta. Or dx is equal to a cosine of theta d theta. Now substitute these in this integral, we get integral 1 by square root of, it's a square minus, now instead of x we have a sine theta, so we write a square sine square theta. Now instead of dx we have a cosine theta d theta, so we have a cosine theta d theta, that is further equal to, it is 1 by, now here we have a square minus a square sine square theta. Take a square common, so we get a root of 1 minus sine square theta, and here we have a cosine of theta d theta, that is further equal to integral of, now here we have a and in denominator here we have a, so they yield quotient as 1, so we get 1 divided by 1 minus sine square theta is cosine square theta, so square root of cosine square theta is cosine of theta. It is cosine of theta, here you have cosine of theta d theta. Now this cosine theta and this cosine theta will yield quotient as 1, so we get integral of d theta. Okay, that is equal to integration of d theta is theta plus constant of integration c, which is further equal to, now here we have x is equal to a sine theta, so that imply x by a is equal to sine theta, which further implies sine inverse x by a is equal to theta. Okay, now instead of theta we can write sine inverse x by a, so we write sine inverse x by a plus constant of integration c. That completes the question. Now our second special integral is 1 by square root of x square minus a square. On evaluating this integral, we will get log of mod of x plus square root of x square minus a square plus constant of integration c. Let us prove this. Here we have to find integration of 1 by square root of x square minus a square. To evaluate this integral, we put x equal to a secant of theta. Now differentiating x with respect to theta, we get dx by d theta is equal to a, differentiation of secant theta is secant theta tan theta, or we can write dx is equal to a secant theta tan theta d theta. Now substitute these in this integral, we get integral 1 by square root of x square. So instead of x we have a secant theta, we write a square secant square theta minus a square, then instead of dx we have a secant theta tan theta d theta. That is further equal to, now we can take a square common, so we get 1 by a square root of secant square theta minus 1. Then here we have a secant theta tan theta d theta. That is further equal to, its integral of 1 by a, now secant square theta minus 1 is tan square theta. Square root of tan square theta is tan theta, so we can write here tan theta. Then we have a secant theta tan theta d theta. Now a tan theta and this a tan theta will yield 1 as quotient, so we get integral of secant theta d theta. Now we know that integration of secant theta is equal to log of mod of secant theta plus tan theta plus constant of integration c. Now we know that x is equal to a secant theta, so we can write x divided by a is equal to secant theta. Now instead of secant theta we can write x by a. Also we know that tan square theta is equal to secant square theta minus 1, or we can write tan of theta is equal to square root of secant square theta minus 1. or tan of theta is equal to square root of, now instead of secant theta we can use x by a, so we get x square by a square minus 1, that is equal to square root of x square minus a square divided by a. Thus we can write log of mod of, instead of secant theta we have x by a, so we write x by a plus, and instead of tan theta we have square root of x square minus a square divided by a plus constant of integration c, that is further equal to, it is log of mod of x plus under root of x square minus a square divided by mod of a plus constant of integration c, which is further equal to, it is of the form log m by n, so we can write it as log m minus log n. It is equal to log of x plus root of x square minus a square plus, minus log of mod of a plus constant of integration c. Now this log of mod of a is also constant, so instead of minus log of mod of a and this plus c, we can write log of x plus mod of x square minus a square plus, instead of these two constants we can write a single constant. Let us write capital C. Now this capital C is this plus c minus log of mod of a. That completes the question. Now the third special integral is 1 by square root of a square plus x square. On evaluating this integral, we will get log of mod of x plus square root of x square plus a square plus constant of integration c. Let us prove this result. Here we have to find integration of 1 by square root of x square plus a square. To evaluate this integral, we put x equal to a tan theta. Now differentiating x with respect to theta, we get dx by d theta is equal to, a is constant and differentiation of tan theta is secant square theta. Or we can write dx is a secant square theta d theta. Now substitute these in this integral, we get integral 1 by root of, now instead of x we have a tan theta, so we write a square tan square theta plus a square. Now instead of dx we have a secant square theta d theta, so we write a secant square theta d theta. That is further equal to integral 1 by Now take a square common, so we get a square root of tan square theta plus 1 a secant square theta d theta. Now we know that tan square theta plus 1 is equal to secant square theta. Square root of secant square theta is equal to secant theta, so we get integral 1 by a secant theta a secant square theta d theta, which is further equal to integral secant theta d theta. Now we know that integration of secant theta is equal to log of mod of secant theta plus tan theta plus constant of integration c. Now here we have x is equal to a tan theta, so we can write x divided by a is equal to tan theta. So instead of tan theta we can write x by a. Also we know that secant square theta is equal to 1 plus tan square theta. That implies secant theta is equal to square root of 1 plus tan square theta. That is further equal to square root of 1 plus, instead of tan theta we have x by a, so we can write x square by a square. That is equal to square root of a square plus x square divided by a. Thus we get log of mod of, instead of secant theta you have root of a square plus x square divided by a, then plus, instead of tan theta we have x by a, so it is x by a plus constant of integration c, or we can write it as log of mod of square root a square plus x square plus x divided by a plus constant of integration c. Now this is of the form log m by n, so we can write it as log m minus log n. That is equal to log of mod of, we write x plus root of x square plus a square minus log of mod of a plus c. Now this log of mod of a is constant, this c is also constant, so instead of this c and this minus log of mod of a, we can write log of mod of x plus square root of x square plus a square plus capital C. So the capital C is equal to plus c minus log of mod of a. That completes the question. Now, in my next lecture, we will do questions based on these special integrals. Till then, take care of yourself. Thank you.